So in this video, we're going to talk about ions and about ionic bonding. The first thing we need to do is discuss the definition of the word ion. An ion is an atom with a positive or a negative electric charge. And you might think, well, what can an atom do to get an electric charge? Well, if you remember, when we talked in the first video about the lithium atom, we said that it had 3 protons in its nucleus, and that meant that if it was going to be electrically neutral, it had to have 3 electrons. So let's draw that out. Here's my lithium nucleus. It has 3 protons, and we'll go ahead and draw its 4 neutrons in here too. Okay, so here's its sort of ugly looking nucleus, and then we said that it has 3 electrons orbiting around it. Now you'll remember that in the first electron shell we can only fit 2 electrons, so in the second electron shell that 3rd electron has to go. So here's our lithium. He has 3 protons and he has 3 electrons. Well, so according to the octet rule, he would really like to just have a full outer shell, right? So he would really like to get rid of this electron. That's what he wants to do. So, and if he can do that, then he'll be an ion. He'll be stable because he'll have a full outer shell, but he'll be an ion because he will have a positive electric charge. Well, how could he do that, you say? Well, let's say that he is close to, let's say that he's close to a fluorine atom. Fluorine is number 9 on the periodic table, so that means fluorine has 9 positive things in its nucleus. Let's draw those. 1, 2, 3, 4, 5, 6, 7, 8, 9. And most fluorine atoms have 10 neutrons as well. So let's go ahead and draw those in there, even though they're not super important to this specific discussion. Just on general principle, we'll put them in. And then let's draw our 9 electrons. So here's 1, 2 in the first shell. We have 3, 4, 5, 6, 7, 8, 9. Oh, so now that we've drawn it out, we can see that our fluorine has 2 electrons in its inner shell and has 7 in this next shell. So it would really like to have another one so that it could follow the octet rule too, right? So that it could have a full outer shell with 8 electrons. Well, this seems like a pretty easy solution, right? If the lithium atom just gives fluorine one of its electrons, then lithium won't have it anymore. It'll come over here to be with fluorine. This whole shell will just go away, poof, just like that. If I had white out, I'd white it out. It would work better. Wait, I do have white out. No, I don't. Yes, I do. This is not the most organized video I've ever made. So look, our lithium atom has just gotten rid of its outer electron shell. And now it's gone. So now, there. So now lithium has a full outer shell of 2, and fluorine has a full outer shell of 8. So they're both stable now, but there's a problem. Since fluorine has 3 positives and 2 negatives, that means that now fluorine has a positive 1 electric charge. And, sorry, this is lithium. Lithium has a positive 1 electric charge. And since fluorine has 9 positives and it has 10 negatives, that means it has a negative 1 electric charge. So now we have 2 stable atoms that have an electric charge, which means they're ions. Now, the next thing that happens, well, it all happens at once, but the next thing to think about is that positive things and negative things attract to each other, right? So, whoop, they just stick together. And now they have made an ionic bond. They have made something called lithium fluoride, a molecule that's ionically bonded together. So that's how ionic bonds work. A lot of times we draw these in a little simpler way because when we're thinking about this, we already know a lot about the nucleus of the atoms at this point. in the semester. So we can save time by not drawing all these little protons and neutrons. So we might sometimes put just Li instead of drawing all this. And we might just put one dot to signify the one valence electron that lithium has, instead of drawing all this business. And for fluorine, instead of drawing everything in the middle, we might just put F, because we all know what's in there. And instead of drawing all of this stuff, we might just draw the Lewis dot structure of the fluorine atom, showing not all of this stuff, but just that it has 7 valence electrons. And that's a much simpler drawing that means the same thing, and it's just as easy, maybe even easier, to denote the transfer of that electron by just going whoop and drawing a little arrow. Now we can draw the lithium fluoride ionic bond and molecule just like that. Super, super simple. So the next video, we're going to talk about a different kind of bond called covalent bonds.